We're going to try to find the remaining zeros for f of x here, and we have a cubic polynomial, and they give us 1, 0. So because we know negative 5i is a 0, what else do we know? We know that another 0 has to be positive 5i. That's the complex conjugate. The real part is 0, so the real part doesn't change, but the imaginary part of the complex numbers, we have to have 1 and its opposite. And then what is the degree of f of x? 3. What is that? What information does that give us?
3 zeros.
We know that there's 3 total zeros. How many do we already know now?
2.
How many do we have to find?
3.
We have to find the third one. One more. Yeah, 3 total. So what are we going to do? We know 2 of them. How's that going to help us? How? What do you mean plug it in? Yeah. Synthetic division. Perfect. All right. Remember, we use synthetic division to break down a polynomial, similar to how if I had, for example, if I had the number 30 and I said, hey, you know what? I know 2 factors of 30. I know that 2 is a factor and I know 3 is a factor, and I want you guys to find the rest. And then you'd be like, oh, well, I'm going to start breaking down 30 to figure out any missing zeros. So you'd say, all right, well, first I'm going to divide by 2 because I know that that is one of my roots. So I divide by that and I get 15. And you're like, oh, and I was also told that I have 3. So I divide by that, and then I get 5, and it's like, hey, I have my last factor. I have found them all. How did we do that? You use the zeros that you're given, and you break it down, and you use your quotient to continue breaking it down. So we don't go back up to the original polynomial. We continue from the quotient that we had when we divided it. That's what the synthetic division does for us. So do you guys want to start with positive or negative 5i? Positive 5i it is. So we have 5i. What is the coefficient of x cubed? What's the coefficient of x squared? What's the coefficient of x? And the constant. Now what? And then? Perfect. What's going to happen here?
59. Oh, wait, you don't be 3 plus
3 plus 5i. Good. You caught it. You're good. It's on video, so that's fine. All right. What obstacles are we going to run into when we're multiplying here? What's that? We have to multiply to both. Here we have to distribute this 5i. So I'm going to kind of do the work to the side here. When we multiply, we're going to have 5i times 3 plus 5i. Well, what is 5i times 3?
15i.
What is 5i times 5i? I squared. But what is 25i squared? Minus 25. So when we multiply here, that's what we get. 15i minus 25. If you put the real part first, so a complex number in standard form, that's fine too. I do not have a preference if the real or imaginary part is first. All right. What is nice about this now?
Cancels out.
What cancels out?
15 times.
And then what's left over?
15i.
All right. Now what do? We multiply these. What is 5i times 15i? 5 times 15? 75. And then I squared, but what is that? Negative 75. So when we multiply here, we get a negative 75. Ugh, grr.
Cancels out, right?
Mm-hmm.
Oh, wait, no, just kidding. Ah!
Yeah. I need my eraser. All right, now what? Does that make sense that this is 0? Why?
Does it cancel out?
Yeah.
Okay, that's what I thought.
You were right. I was writing it down, I remember.
Oh, I didn't see.
I know.
I'm confusing myself.
All right, why does this make sense that we would get a 0 here? Because we know it's one of the zeros, and if you have a 0, the remainder is going to be a 0, okay? Where do we go from here? Now we want to do the same thing with negative 5i. All right, now I want to redraw your attention. This is what we did. This polynomial here, that's like our 30, and this is like our 2. So we divided, and our bottom row here, this is like our 15. This is the quotient. We didn't have a remainder, so we just divided. This was our quotient. Now I'm going to divide by the other 0, but I'm breaking this part down. I want to break this down further. And so that's where we're going to use our other factor, and our other factor in this case is negative 5i. So we bring this down, and when we multiply, what do we get? And now what? When we add, imaginary terms cancel, we're left with 3, and now multiply and you get negative 15i, and what is our remainder? 0. All right, so does that make sense? Yes, because what did we know also about negative 5i? So by the complex conjugate theorem, if you have one conjugate root, you must have its complex conjugate, all right? Or one complex root, you'll have the conjugate. So what is this? What is this factor here? X plus 3. We're trying to find the 0, so what do we need to do? Set it equal to 0, and then when we solve, we get negative 3. So it turns out then that our zeros are going to be negative 3, 5i, negative 5i, and these were the remaining zeros. So technically, it would be these two that are the answer. If you put all 3 on a quiz or a test, I would take that answer. Make sense? Yep, that's it.